Hello everyone, my name is Joshua Shute, and today I'm going to talk about the 1-bit sliding window protocol. Alright, so some of the reasons why you'd want to use a 1-bit sliding protocol are that it's simple and easy to understand, it's relatively reliable, and it requires less bandwidth than some other protocols due to acknowledgement bits. We'll talk about acknowledgement bits later, they're very helpful to this. However, before you start using the 1-bit sliding window, there are a few problems I'd like to go over. First off, issues arise if both servers send an initiation frame at the same time. We'll also go about this later. Um, Also, there are better methods that require less bandwidth than using the 1-bit sliding window. And another problem is that it's not too great for high latency communication, such as like satellites or long distance wires. It's not the best for it, and there are better methods out there. Alright, so now we're going to discuss the bits that are in the header part of the each frame. So each frame is sent with 3 header bits, and these bits are the sequence, the acknowledgement bit, and the packet number. So the protocol uses the stop and wait system, and this allows both servers to wait for the packet that each is expecting to receive. And it checks this by using the acknowledgement, or the ACK bit for short, before sending the next frame. Now this does present an issue in the fact that you can't send 2 different frames at the same time, but it does make things a lot simpler and easier to debug. Let's go to the next slide. So here's the process, and I'll explain how it works. So we're going to have server A right here. This is server A, and we have server B. Okay, so server A wants to send a frame to server B, and this is the initiation. Yeah, I'll write it out. Let's pick green. So this is the initiation frame. So that means A is starting to send a signal to B. And so A sends a frame to B with a sequence number of 0 and an acknowledgement bit of 1. And so B receives this. And so what B is going to do with this once it receives the frame is that it's going to take the sequence bit and put it into the next frame as the acknowledgement bit. And so it'll send this back to A, which is what A was expecting to receive. And once A receives this, A is going to flip this bit, the sequence bit. It's going to flip it, and it's going to take the acknowledgement bit just like B did and put it over here. And so it'll send it back to B, and then B will receive it, and then do the same process as well. It's going to take the sequence bit and put it into the acknowledgement bit. However, B does not flip these 2 bits. It does not flip the sequence bit. So this process gets repeated all throughout, and information can be transferred this way. This is used because this is the stop and wait system, because it waits for the other server to receive it and tell it that, hey, I received this frame. And this is what the acknowledgement bits are for. A lot of information can be passed this way, but fundamentally it does require more bandwidth and has a lot of latency issues because of the stop and wait system. Another issue is shown over here in this section, is that if both send an initiation frame at the same time, things get really jumbled and hard to read. So A, for example, sends an initiation frame to B, and B sends an initiation frame to A simultaneously. So B, now that it got this initiation frame, thinks that it needs to send the same protocol back. So it's going to take the sequence bit before, make it the acknowledgement bit, and do nothing with the sequence bit. And so it sends this back to A. And so A receives this, and then sends this, the same protocol, acknowledgement bit, and flip this bit, sends it over to B. And once it does this, see both servers over here are doing this simultaneously, and it just gets really complicated and fundamentally messes up with the data. And so the big question I'd like to ask the audience is, what are the names of the 3 header bits that the 1-bit sliding window protocol uses? This is very important for the 1-bit sliding window protocol, and we have a hint over here. I would like to know what these acronyms are for. Well, not necessarily acronyms, but abbreviations. I'd like to know what these are used for and what they actually are. Thank you.